So in the last class, we have discussed about Nexus switches, in which we were having the fixed switches and then modular switches, then modular switches. This is what we have discussed in the last class. Then we have explored the chassis switches. We have seen 9504, 9508, 9516. Just now again we'll start exploring our ACI fabric, because first of all we are starting with ACI. So on day one we have discussed what is ACI, why do we need ACI, right? Because we have the switches, or the switches can be managed either manually or you can manage them through APIC controller, application policy infrastructure controller, and the APIC is part of, or this ACI is part of SDN technology, software defined network technology. So we have SDN solutions for local area network, wide area network. Likewise, ACI is one of the solutions for data center network for the automation. So we can configure our Nexus switches from a centralized controller. And that centralized controller is known as APIC, application policy infrastructure controller. So in the last class, we have discussed about the basic fundamentals of the Nexus switches, which we are going to use in our data center, right? So here in the APIC, when we talk about this whole concept, we have these three main components. We have these three main component in ACI now. So first of all, we have the spine switches, which we have already discussed. We have discussed about leaf switches also. Now we're going to discuss about APIC as well, application policy infrastructure controller. So if you look at this, first of all, spine switch do what? Spine switch represent the backbone of the ACI fabric. Yes, we are well aware of this. Connected to the leaf switches, but there is no connectivity between spine to spine. Leaf connect to spine, spine connect to leaf only. Then you have the leaf switches, represent connection point for end devices, including the application policy infrastructure controller. So the leaf switches will provide connectivity to the endpoints as well as to the APIC and connected to spine switches. But again, there is no connectivity between leaf and leaf switches. Last but not the least component we have is the APIC, application policy infrastructure controller. What APIC is doing here? APIC is unified point of policy enforcement, health monitoring and management for the Cisco ACI fabric. So whatever you are going to do in the future, you are going to make the configuration on your leaf and spine switches, policy configuration, monitoring policies, health monitoring, events, faults collections, software upgrades, configuration backup. All these tasks will be performed on this controller only, known as APIC, application policy infrastructure controller. But last point is very important to understand here. Not involved in data plane forwarding. And this statement is true for all other solutions as well. Like if you talk about Cisco DNAC or Cisco SD-WAN. So in Cisco SD-WAN we have controllers like vManage, vBond, vSmart. So they never participate in data plane forwarding. What does this means, guys? What does this data plane forwarding means? Anyone here? We'll put some lights on this data plane forwarding. What does this means? No, data plane forwarding. Very good. So actually you see here, what we do. Let's say we have two switches, normal switches, and then we have connected two interfaces here. So the first thing what will be running on this switch is there's a protocol normally running, spanning tree protocol. What STP will do? STP will send BPDUs. STP will send BPDU on both interfaces, and for the first time switch 2 will also send the BPDUs. So there's an exchange of BPDU between switches. One of the switch will become root bridge, so designated port, and one of the interface will become alternate port. So if you look at this BPDU message, this message was sent by the switch for the switch. So this is considered as a control plane traffic. But with the switch, there's a user connected. Then there's also a user connected. If this user has an IP address 10.1.1.1/24, IP address is 10.1.1.2/24. Let's say this user is sending HTTP traffic to that another user. HTTP is based on TCP. Then there is a source IP and destination IP. Source IP is 10.1, destination IP is 10.1.1.2. Then first ARP request will be sent, and after the ARP request they'll be adding source MAC and destination MAC. So source MAC and destination MAC will be added. Traffic given to switch 1 will give it to switch 2, switch 2 will give it to the user. So this traffic will be considered as data plane traffic. But before forwarding this data plane traffic, in this case you have to run a spanning tree protocol. Let's say it is a layer 3 communication. So in case of a layer 3 communication, we have to make sure that routing protocols are configured successfully. If the routing protocols are configured, routing table is built right through the OSPF, then what we can have, we can forward the user traffic. So OSPF hello message is control plane traffic. In that case, OSPF hello message is our control plane traffic. Okay, that is the control plane traffic. So here when we say data plane, it means that we're talking about the user traffic. So that's why the Cisco APIC, like we said, Cisco APIC is not involved in data plane forwarding. It means that when two users communicate, they has nothing to do with the APIC. APIC will never participate in that traffic flow. Okay, so Cisco APIC is going to solve it. Cisco APIC is just participating in the management plane. It handles the management plane concepts. Then this is one of the advantages of having the APIC, guys. Now if you look at this from the NXOS perspective, what we are doing in NXOS perspective, in case of NXOS perspective, if these are the switches, let's say switch number 1, 2, 3, 4, 5, 6, 7. So right now we have just 7 switches, which is not a big number, right? But still, if you want to make the configuration, how you'll do that? You log into the Nexus 1 first, make the configuration. Then you log into Nexus 2, Nexus 3, Nexus 4, Nexus 5, Nexus 6, and Nexus 7. So like this, you will log into each and every switch one by one. To each and every Nexus switch, you will log into them. And once you make the configuration on the first switch, you'll take the configuration in a notepad file. This is a very common practice. You'll make the changes, then you'll copy it and you paste to the second switch. Then you copy it to paste to the third switch. That's how we make the configurations in NXOS mode. But this thing is very hard to scale. Harder as we scale. That's why now if we see the other side of picture here, in this case we have spine and leaf switches. Now in this case, as an admin, we are not supposed to log into the switches individually. No, we are not going to log into the switches individually here. What we will do in this case, we have leaf and spine switches as you can see here. but we also have the controllers. And this time, this is known as APIC cluster. This is known as APIC cluster, application policy infrastructure controller cluster, because I'm not having just one APIC. We have also had some discussion in the last class also. So you always start with 3 APIC. We'll discuss the why do we need 3 APIC for the cluster, but you have 3 APICs this time. And then as an admin, our job is still secure, guys, if you know how to manage the APIC. But as an admin now, we are not going to deal with the leaf and spine switches. We are going to deal with the controllers. So as an admin, you log into the controllers, and then from the GUI access, you'll start pushing the configuration on leaf and spine switches. On leaf and spine switches. So when we'll talk about this initial configuration of the fabric, we'll discuss about this, that how the communication is offered, or how we'll make the initial configuration on the Cisco APIC. Because the best part of this ACI technology is you don't need to configure anything on the leaf and spine switches for the first time. First, you'll just make the initial configuration on Cisco APIC. APIC will automatically discover your leaf and spine switches. So we'll talk about fabric discovery. So at the time of fabric discovery, I'll explain how it works, and you'll see that it's completely automated. Cisco APIC will automatically discover your leaf and spine switches in this scenario. Leaf and spine switches will be discovered automatically. Okay. All right. Any question, guys, till now? Okay, please feel free to ask whenever you have any question. Don't hesitate, okay, guys. Feel free to ask anytime. Then, yes. So it is the controller. Like we have vManage, and in local area network we have DNAC, DNA center. Likewise, we have Cisco APIC in ACI. Yeah, okay. So we'll discuss about this data plane forwarding also later. But for right now, you remember that when we were talking about this leaf and spine switches, and we have configured VXLAN earlier also. Earlier we have configured VXLAN. You remember, right? But here, how we will provide the underlay connectivity in ACI fabric. How we will provide the underlay connectivity in the ACI fabric. So if we look at this, we have ISIS fabric infrastructure. So now, guys, on leaf switches, we are going to configure VTIP IP address, and this thing is going to be automated. We'll discuss how. VTIP addresses, VXLAN tunnel endpoint address, and VTIP address. You remember, while we were configuring the VXLAN manually, we have configured what? We have configured OSPF as an underlay protocol. Remember, guys? In this case, when you are going to have the Cisco APIC or Cisco ACI solution, in the underlay to provide reachability from VTIP to VTIP, we're going to use a protocol known as ISIS. The protocol known as ISIS. ISIS stands for intermediate system to intermediate system. Intermediate system to intermediate system. We got this term from OSI model, guys. In OSI model, router was known as intermediate system. The term router was given a very later, like in TCP IP model. Earlier it was known as intermediate system. So then they have designed this protocol which is running between routers actually. So they gave it a name ISIS, intermediate system to intermediate system. But the best part is when you deploy ACI, you don't need to learn about ISIS protocol. ISIS provides IP reachability among WATEP addresses automatically deployed. No user intervention is required, and that's why no ISIS knowledge is also required, because you are not going to execute even a single command to configure ISIS. It's fully automated, guys. It is going to be configured by Cisco APIC on your leaf and spine switches. So in the underlay, we are going to use this protocol ISIS for the reachability between the VTIP, because either it is your normal network, you are going to use VXLAN, or if it is Cisco ACI, still we are going to use VXLAN. But to provide the reachability for the underlay, we have now ISIS. Again, ISIS is a link state routing protocol. Mainly it is covered in service provider trainings. Like if you go for service provider trainings, or you go for CCI enterprise, you learn about ISIS protocol, that what is ISIS or how it is configured. But ISIS and OSPF are almost similar. OSPF and ISIS are almost similar, guys. Yes. No, between the leaf and spine and leaf, so that you can provide the underlay reachability. ISIS. Yeah, see, actually, VTIP is not a device. VTIP is just an address on the switch. So I'm not configuring ISIS on the VTIP. I'm going to configure ISIS on the switches. Yeah. Yeah, again, I'm saying that it's automatically configured. It will be configured by the Cisco APIC. That's why you see most of the tasks are automated now in ACI environment. No, it's not a management IP address. I think you missed the VXLAN classes. Which IP? Management IP? See, for the first time when we build this ACI fabric, we are going to configure APIC. Okay. So we'll configure management IP on APIC only. We don't touch our leaf and spine switches. Once you're done with the APIC, APIC is connected to the leaf switches. APIC will discover all of your leaf and spine switches. Then from APIC, you can configure management IP addresses on your leaf and spine switches, but you'll configure it from APIC. Okay. And two types of management IPs can be configured here, known as out of band management and in band management. We'll discuss about this. But for the first time on leaf switches, we are not making any configuration. It's completely automated. The Cisco APIC will push the configuration to your leaf and spine switches. Enterprise network, or the data center network. ISIS is moreover a service provider routing protocol. It was used in service provider networks. But now if you learn about, yeah, not even in enterprise also, but now if you learn about controller based networking, okay, they are giving preference to ISIS. If you talk about Cisco DNAC, which is used in local area network, which is used in local area network. So Cisco DNAC is also deploying ISIS for underlay reachability in your catalyst switches. Likewise, when we talk about Cisco ACI, so we have Cisco APIC in data center network. So this Cisco APIC is also doing what? It's also deploying ISIS for underlay reachability. Okay. It's now getting popular again in the networks, yes. But it now is used in data center as well as in local area networks. Yeah. All right, guys. Then let's come to the APIC. So in the last class, we have explored the Cisco Nexus switches, but now we're going to explore the APIC, which first of all, it stands for Application Policy Infrastructure Controller. So all of you guys are well aware of the role of APIC in our ACI solutions, right? Actually, we don't have option to add a text box in this encode application, so I have to just copy a text. I'll paste it here, and then we'll have the text box. APIC is the brain of the Cisco ACI technology. It is taking, or it is part of the management plane. It does not forward user traffics. It is part of the management plane. It is not going to forward user traffic. It acts as the center of the configuration management, troubleshooting, upgrade, configuration backup in a ACI environment. So that's why the controllers are also given a name, guys. Single pane of glass. We use a term here in the software defined networking known as single pane of glass. So the Cisco APIC is going to act as the you can say single pane of glass. The hardware or APIC hardware is based on Cisco UCS servers. You might have heard of UCS, guys. This is a product family from Cisco. Unified Computing System. So Cisco introduced APIC in 2009. Actually, Cisco was just selling the switch and routers, firewall and all, but they were not having any product for storage and as a server. So you have, IBM, HP, Dell, like this. But then Cisco said that, okay, let's have some storage appliance, or you can say server appliance also. So in 2009 they launched a series known as UCS, Unified Computing System. So now our Cisco APIC is a software, but you know that in order to run it, if you want to run the software, you need hardware, right? So the underlying hardware is Cisco APIC, guys. Oh, sorry, Cisco UCS, Unified Computing System. So in unified computing system, you see that we have multiple types of servers. You will notice you have UCS B series, UCS C series, UCS S series. But here specifically when you talk about Cisco APIC, we are using Cisco UCS C series. We're not using B series because B is known as Blade series, Blade chassis. So we are using the C series servers for Cisco APIC hardware. We'll come to that part. We'll explore Cisco official website also for the product line for Cisco APIC as well. APIC is connected to the leaf switches in a dual horn manner, or you can say having dual horn connectivity with the leaf switches. You can connect it to just one leaf switch also, because it's not a condition, but it is always recommended to provide dual horn connectivity. Dual horn connectivity means connect it at least with two leaf switches. It can be deployed as a standalone appliance or a cluster, having at least three epics. So three is the minimum requirement to build a cluster, but it can go up to 5, 7 or 9 epics. And you know that why the cluster is helpful. Okay, so this is acting as the center of your topology. Now the hardware specifications depends on the appliance to appliance, APIC to APIC. We have APIC for medium size network, for large size network also. Because it's always a better idea to get the information from the official website as compared to any other source of information. So here we'll explore the fixed switches. Okay, management platform and controllers. We'll go to the ACI part. In the last class, there was an option for APIC also. 9000 series. Okay. Cisco APIC hardware. This is not that document. Okay. First of all, what is a Cisco APIC? As we have discussed, the infrastructure controller is the main architectural component of the Cisco ACI solution. It is the unified point of automation and management for the Cisco ACI fabric, policy enforcement and health monitoring. The APIC appliance is a centralized, clustered controller that optimizes performance and unifies the operations of physical and virtual environment. The controller manages and operates a scalable multi-tenant Cisco ACI fabric. So these are the main features of this Cisco APIC, guys. These are the main features of Cisco APIC. Application-centric network policies, data model-based declarative provisioning, application and topology monitoring and troubleshooting. But it can also be integrated with third-party solutions. This is going to be very interesting once we'll discuss about the firewall placement, the load balancer placement, as well as integration of Cisco APIC with virtualization. Image management. Now, if you want to upgrade any of your leaf or spine switch, don't have to follow the traditional approach. You can just do one thing. You can download the official image from Cisco website, upload it to Cisco APIC, and from Cisco APIC you can start the upgrade process. Cisco ACI inventory and configuration. Inventory means the leaf and spine switches. Implementation on a distributed framework across a cluster of appliances. Health score for critical managed object. Fault event and performance. This is what it's going to centralize. So every function is going to be centralized other than the data plane traffic, because data plane traffic is still going to be forwarded through the leaf and spine switches. Data plane traffic will never come to the Cisco APIC because it's not going to be participate in Cisco APIC at all. Sorry, in data plane at all. Then here we have APIC series switches. Then you talk about M4, L4, M4 medium, right? Likewise, when we talk about Cisco UCS switches or Cisco UCS C servers, C series servers, there's a product family from Cisco. Cisco UCS B series, C series, and Cisco UCS S series. So there are families, guys. They're like M8. This is the latest one. You have M8, M7, M5. But now when we talk about APIC, we always make sure that we are going to use the latest version. Otherwise, you can have M8, M7, M6. There was M5 also, right? Like you have M5 as well, but it keeps upgrading and they keep adding new and new features. So the underlying hardware is always going to UCS C series servers. This is not part of our course curriculum because it was designed for Nexus plus ACI, but now we're going to have this discussion. We'll be having a discussion on this UCS C series servers also, and we'll talk about the compute part. But right now our focus is on Cisco APIC. So let's come back to the discussion here. If you have a medium size network, you can go with APIC M4. APIC with medium size CPU, hard drive and memory configuration, it can manage up to 1200 as ports collectively. It's not giving us the number of these switches, but it is giving us the number of ports it can manage. Large L4, it can go more than 1200 as ports also. But this guide is not giving us the hardware. Yeah, here it is. You look at this. And if you look at Cisco UCS series switch servers also, you'll see the same hardware. The only difference is the labeling. So you will get the label as APIC on this right side. APIC L4, M4 and APIC L4. So if you talk about this APIC M4, it has memory 16 GB of RDIMM 3200. Okay, so 8 GB in total. Default unit 6. Hard drive 480 Gbps. SSD 960 GB SSD. PCI Express. Power supply unit. This is the power supply requirement. Fan. It has 8 hot swappable fans. Hot swappable fan means that in a running situation you can add or remove the fans. Remember guys, airflow, there were two types of airflow. Remember? Hello. Right. Yes. So front to rear and rear to front, right? So in this case, you have front to rear cooling. Okay. Now, when it comes to the connectivity, first of all, you have Cisco APIC, which we are going to connect to the leaf switches, but we also need to manage our Cisco APIC from outside also. I want to access the GUI access. I want to access it through Telnet, sorry, SSH, so that I can access the GUI as well as the CLI of my controller or my APIC. So in this case, we have options, guys. When you connect it to the Cisco ACI fabric, so the Cisco APIC will connect to the leaf switches, but it is also connected to an out of band management network, also a dedicated management network, a dedicated management network. So on our on our Cisco APIC, we have two types of interfaces: bond 0 interfaces and bond 1 interfaces. On Cisco APIC, you'll see two types of interfaces: bond 0 interfaces and bond 1 interfaces. So bond 0 interface, as you can see here, they are providing connectivity to the ACI fabric. Means they are providing connectivity to the leaf switches. And then we have the bond 1 ports, which is connecting us to out of band management. This is connecting us to out of band management. So even if your Cisco APIC is not connected to the leaf switches, still you can get access through the out of band management. That's why we have separated this connectivity, the connectivity to the rest of the fabric and out of band management connectivity, so that in case even our leaf switches are not up and running, so still we'll be able to reach to the Cisco APIC and we can get the access. We can get the access. That's why we always have this out of band management connectivity here using the bond 1 ports. So we have bond 0, bond 1. If you look at here, so if you remember, the Cisco APIC is, as we were talking about this in the last class, do we have a picture? Yes. So if you look at this is the Cisco APIC, right? And as we have discussed, Cisco APIC is connected to whom? Cisco APIC is connected to the leaf switches. So now here we just see a box and then we have connected it. But in actual appliance, we have types of interfaces dedicated for this. This is just for the visual representation. So you're asking connectivity to what, right? So Cisco APIC needs to be connected to the leaf switches. Yeah, dedicated management port, so that you can access GUI as well as CLI of the Cisco APIC. Because you're this in, yes, No, see, APIC is going to manage this leaf and spine switches using this port connectivity. It's not need a dedicated management port for this. That's why in this we have an infrastructure VLAN and we also have an infrastructure TNAND. So when we'll discuss about this fabric discovery, at that time we'll discuss about infra VLAN also. Okay, so it is not going through the management port. Even on the spine switches also, on leaf switches also, they have a dedicated management port. And for this guys, we always plan a dedicated management network also in any kind of network, you'll always see. And the management interface of all the appliances is going to a dedicated switch. And even your, let's say Cisco APIC is also connected to this switch. And then somehow we are also connected to this switch, through that we are able to access this management interface IP. And the data plane connectivity is different and this connectivity is also different. So all devices has their management plane and we always have a dedicated management network which is known as out of band management. We don't want any kind of communication related to the management over data ports. That's why if you remember, if I give you a quick idea of this, earlier in the switches or routers, if you will notice, like if I talk about Catalyst 2900 series switches or Cisco router 1841, what they do have, they have normal data ports and they have just one console interface. So this is a router and this router has two data interfaces. One is app0/0, another one is app0/1. Another one is app0/1, and on this router we also have a console interface. But now guys, through the console interface you should always be present nearby the device. If I am 500 kilometers away, can I access a router via console? Is it possible? Hello. It is possible, but we have to use a trick. There must be a person in the company who will connect this laptop to the console and then you'll take RDP access. Using this you can access it, but that's not a feasible solution. That's why I need Telnet or SSH access. But even if you look at the putty, if I open putty and in putty if I click on serial connection, which is for console, it is not asking me for an IP address. It's just asking the COM port. But if I choose either SSH, it will start asking you for an IP address, that okay, put the IP address. If you choose for Telnet, again it is going to ask for an IP address. So without IP address you can't access Telnet or SSH. Now we got a problem. The problem is, in this case, either you can configure an IP address on this interface or you have an IP address on this interface. So if I want to access my router from a remote location, how I'll do that? I'll use one of these two IP. Either I'll use 10.1.1.1 or I'll use 20.1.1.1. Yes or no? But serial. See, that serial port is not here. Serial port is having speed 1.54 Mbps. So in most of the appliances, you'll not get the serial type of connectivity. If you're talking about that serial link, okay, you might be talking about auxiliary port, but you're missing it with serial. Serial is a separate kind of connectivity. Serial is a type of cable actually. Earlier we were having Ethernet and serial, but nowadays we don't use serial cables anymore. Hello. Hello. Okay. So now the problem is the f0/0 or f0/0/1, they belongs to the data ports, because this is for the user traffic. The users are sending traffic like this to each other. But now if I want to access this router from remote locations using telnet and ssh, so telnet and sss traffic is also management traffic, because it is not related to the user traffic, it is just for the management of the network. So still that traffic will be forwarded towards the data ports. This kind of scenario is known as in-band management. This kind of scenario is known as in-band management. But what we did, we say that, okay, this is not a good solution for networks, because it can mix with our data plane traffic, or it is going to reduce the bandwidth of our data plane traffic. That's why nowadays, if you look at latest appliances, all that is appliances have a dedicated management port, guys. If you'll notice on a physical switch or router or firewall, any device, you will always see what? You will always see a management interface. Now, what is the difference between console and management? See, the ultimate purpose is same, but on the management interface, I can configure an what we can do, guys, we can configure an IP address, and using this IP address we can have the reachability or routing, and through that even I can reach to this router from a remote location. But now if I want to do the telnet ssh, whatever I want to do with this router, I don't need to go to this interface or this interface. My management traffic will be isolated. So this kind of management is known as, by the way, it's a CCNA topic, but okay, no worries. Now I hope it makes sense what is in-band management and what is out-of-band management. Is it clear, guys? Okay. So we are talking about two types of interfaces, bond 0 and bond 1. So bond 0 and bond 1 interfaces Cisco APIC. Could have written it by ourselves also, but it will take more time, guys. So it's better to just use this method. So we have bond 1 interface and we have bond 0 interfaces. Bond 1 interfaces are doing what? Sorry, bond 0 provides the fabric connectivity. This bonded interface connects the Cisco APIC to Cisco ACI fabric, typically by linking to two leaf switches. It carries all production traffic for the APIC role as a fabric controller. And it is configured to provide high availability using multiple physical connections for a single logical interface. Then we have bond 1 interfaces. This bonded interface is used to connect the APIC to a separate out-of-band management network. It handles all management traffic, such as initial setup, troubleshooting, and out-of-band management tasks. This interface provides a dedicated path for management, preventing it from being affected by production traffic issues on the fabric. Because that's why our out-of-band network is going to be completely isolated from the data plane traffic. From the data plane traffic. Kind of a backdoor entry, right? So is it clear, guys? It makes sense now. Still there is any confusion with the out of band or in band, please feel free to ask. I hope it makes sense now, right? Okay, we were talking about APIC. Then now we'll start with the clustering, but visit this download section. So in this download section, we'll have APIC. Okay. Application Policy Infrastructure Controller, APIC software. So this is the latest release 6.0, but it is always recommend to install the stable version. Let's say if the latest one is 6.1, so you can go with 6.0. So we have ISO file available here, and the file size is almost 4 GB. But to download this particular image, you must have Cisco account, Cisco credentials. Once you log in with Cisco credentials, you can download this file. But when you purchase a Cisco APIC for the first time, you will get this APIC installed on the server already. So you'll get the full, or you can say platform, hardware plus software. But later on, if you want to upgrade it and all, then you can visit this official website. You can download the latest image, and then you can start the upgrade process. Then you can start the upgrade process here. Now when we talk about Cisco APIC cluster, guys, because it can be deployed as a standalone appliance or it can be deployed as a cluster of APIC. Now who decide this? You decide this. Right now, guys, I'm not going to focus on this, okay? I'm just telling you here initial setup script of Cisco APIC. We are not going to discuss about it. We'll discuss about this in the fabric discovery, but I just want to show you first thing. When you do the first time installation of Cisco APIC, when you do the first time installation of Cisco APIC, do we have a clear image? Okay, let's use this one. Copy image and paste it. Guys, right now, don't focus on any other stuff. Just focus on this thing. When you do the initial setup of your Cisco APIC, it is going to ask you one thing. Enter the number of controllers in the fabric. This thing is going to decide that you're going to deploy a cluster of APIC or you're going to deploy a standalone APIC. We'll discuss about this whole process in the fabric discovery, but for the moment, you see that you have range from 1 to 9. In most cases, now you'll see in the bracket 3. In the latest one, you'll not see option 1, you will see option as 3. If you'll enter, it will consider that you are going to deploy 3 APICs. But then you can choose your number here. Let's say you are going to deploy 1. So you can say 1. So this thing is going to decide that you are going to deploy a cluster of APIC or you are going to deploy a standalone APIC. You're going to deploy the standalone APIC. A Cisco APIC. Yes, right. So a Cisco APIC cluster is what? It's a group of 3 or more controllers that together manage the entire ACI fabric. This ACI fabric is having what? The ACI fabric is having leaf and spine switches. The ACI fabric is having leaf and spine switches. The reason for deploying cluster. high availability, because in case if you have just one APIC, standalone APIC, then we are having single point of failure. If that APIC goes down, we would not be able to make new changes. See, data plane traffic will keep forwarding, but still will not have any new changes because now our controller is down. So we would not be able to make new policies or new changes. Workload sharing, you have a lot of leaf and spine switches. So instead of just one APIC managing all of them, we can have multiple APICs and they can share the load among themselves. And then we have fault tolerance. If one of the controller fails, the other controllers continue working. These series servers, yes. S series, yeah. No, it is supported on C series, but because the hardware requirements are fulfilled by the C series. Yeah. All right. Then at any given time, one APIC acts as the primary APIC, or you can say lead. So the APIC is automatically get elected, okay, because there is no human intervention is required. One of the Cisco APIC will be elected as the leader, and that leader will do what? You will make the configuration on one of the leader, but that configuration will be replicated on rest of the APICs also. But there's a very interesting option, guys. You know, by default, when you're deploying a cluster, you deploy at least 3 APICs are required. But then in this, we also have an option. I think this screenshot is from an outdated version, but you know, in case of latest deployments, we have option of a standby controller also. So let's see, if you have a cluster of 3 APIC, then you can deploy the 4th APIC also, and that 4th APIC will act as the standby. The 4th one will act as the standby. The 4th one will be used to do what? The 4th one will be used to replace your failed APIC. So let's say you have 3 active APICs, 1, 2, 3. If one of the APIC goes down, still you can work with 2 APICs, no problem. But again, if we could afford, then we can deploy 4 APICs, and one of the APIC will remain in standby node. So active controllers, minimum 3 active nodes are recommended. Share the load in the management plane. Database is replicated to up to 2 other controllers. We'll discuss about this. Standby controllers, they do not participate in policy configuration or management. They are just waiting for their turn. They are just waiting in this silent mode, that okay, in case if the active APIC will goes down, we are going to replace them. So this is going to replace the active controller in case of a failure. Then you notice what is the second line here. It can replace active controllers when needed. Now, configuration is not replicated. Like if I am configuring policies on one of the master APIC, the policies will be replicated on the active controllers, but the policies will not be replicated on standby. But here are automatically updated with firmware updates. That's an exception here because if you upgrade these APICs to the latest OS operating system, and if this standby is running outdated OS, then there would be a problem. If the APIC goes down, this standby controller will not be able to replace it because it's not compatible. So if you don't replicate the configuration, no problem. But if you are going to upgrade your APIC cluster, the firmware update, that firmware will also be updated on the standby controller as well. It's automatically updated on the standby controller as well. On the standby controller as well. Now guys, you might be thinking that okay, you have one APIC is considered as standalone. Makes sense. But can't we build a cluster of two APICs? Why do we need three APIC at least to build a cluster of APICs? Why? Any guesses? There's a concept of majority guys in APIC, because let's say if you have three APIC, APIC 1, APIC 2, APIC 3. So now in case of APIC, if one of the APIC goes down, still we are left with two APICs. So out of three, two are still available. So it means that these two APICs are still in the majority. So if two APICs are available, the cluster still operates normally. You still have the read and write access. But in case guys, if one more APIC goes down, so if only one APIC is online, you are going to lose the write access. The cluster becomes read only. That's why this is known as a split brain conditions or split brain situations, and that's why it's always recommended to have odd number of APICs, 3, 5 or 7. In case of failure, you can have a majority voting so that you can make a decision and you can still have the control over your fabric. Otherwise, if there's only one APIC which is live out of a cluster of 3, then that APIC will not be able to make any changes. That APIC will just get the read only access. The write access will be lost. So that's why it always a concept of majority here, and it is recommended to have odd number of APICs so we can manage the failure. Okay, makes sense. Hello. Yeah. Sorry, 5 APIC for what? Yeah. Nine, up to nine you can have in a cluster. So if you look at this, you have the range. Yeah. So let's say if you have four APIC, in four APIC also guys, they're going to lose the majority election because if you have four APIC, let's say, if you place four APIC in a cluster, you can do that, but it is not recommended because if you have four APIC, APIC 1, 2, 3, 4, let's say out of these four APIC, two are down and two are alive. So you are not in the majority, you are half of the cluster because total we had four, but now only two left. And if we would have five at the time of at the place of four, then we have more chances of having the read access, sorry, write access only. In this case, if two APIC goes down, so we know that total we were having five, but out of five only two went down, so we are still in the majority. So if you are still in the majority, you will be having read write access, read write access. So the APIC cluster use this option here of odd and numbers because it gives us